Good afternoon. Altech Chemicals is an Australian company. We're listed on the ASX. Our vision is to be one of the largest producer of high purity alumina. So if you remember your chemistry, alumina is aluminium oxide, and high purity alumina is 99.99% pure. We intend to build a 4,500 tonne per annum plant. Now let me talk to you about sapphire. Sapphire is actually formed from alumina under intense pressure and temperature. So much the same carbon forms diamond, alumina forms sapphire. Now sapphire has the blue colour, and the colour that is from impurities in the alumina. Iron and chromium creates the blue colour in sapphire. But today if you want to make synthetic sapphire, which is on your watch face or on your camera lens on your iPhone, you want a crystal clear gemstone. You don't want any colour in it. So you need to start with high purity alumina, or 99.99%. Most of our demand in the product of the high purity alumina is in the Asia Pacific region. But what's interesting is that the price is exponential as you go up in quality. So smelter grade alumina is around $400 a tonne. 3 nines is worth $6,000 a tonne, and 4 nines is worth $27,000 a tonne, or $27 a kilo. So it's a high value product. The way they make synthetic sapphire, basically they buy high purity alumina, they put it into a furnace, heat it up to 2,000 degrees, nearly as hot as the sun. Alumina melts, and they slowly grow a single crystal of sapphire, which looks like a big ice block, but it's nearly as hard as diamond. That's actually sapphire gemstone. So the only way they can cut it is using diamond cores, and from that they have slices of that, which is actually the sapphire wafer. Now the sapphire wafer in this slide here is the building blocks of the LED industry. So in order to make an LED, which is a light emitting diode, you start with a substrate, you put some chemicals on it, some electronics on it, and that sandwich is actually a semiconductor. Now, they found that when they put electricity to a semiconductor, it produced all these light photons. And they realized that 90% of an energy goes to LED, produces light, where the conventional globe, 90% of the energy is wasted as heat. So this is where LEDs is now becoming the lighting of the future. So I don't know about the UK, but in Australia, everything is going to LEDs, domestic lighting, billboard lighting, concerts, auto vehicles and so on. So that's a very efficient energy system. And this is the fundamental growth of our industry. So LEDs is the big growth. The other growth that's very exciting is in the lithium battery industry. So you heard of the battery fire from Samsung. So when a battery overheats, what actually catches the light is a plastic separator. So there's a plastic separator that separates the positive and negative terminals, and these plastic separators catch a light. So now they're demanding that these become fire retardant. So they are spraying high purity alumina to make them fire retardant. So these are the two fundamental growth of high purity alumina today. And this is a picture of the plastic separator in a lithium battery. The other exciting area of growth is in your smartphones. So your camera lens or your start button on your phone. And some manufacturers like Vertu or Cryocora and HTC have gone to full sapphire screens. Who gets annoyed when their phones get scratched in your pocket because your key scratch it? Well, the future is actually sapphire glass on your phone. So how hard is this material? Most of the gentlemen around will have sapphire crystal on their watch faces. You know, in the early days as a kid, you used to have scratches on your watch, and you wonder why today you never have any scratch. Well, that is actually sapphire gemstone on your watch face. You just look in the back of your watch, it'll say sapphire crystal. Now this is the glass of the Apple Watch. The very complicated scratch test here, so it's going through now a drill. So, gentlemen, you can try that at home. Put a drill through your watch, and if it goes through, then you haven't got sapphire glass on it. But the reason it doesn't scratch is because the drill bit probably has a hardness of a 7, and your sapphire face is actually a hardness of 9. It'll never scratch it, okay? So the whole market itself is about 25,000 tonnes per annum. It's expected to grow to 86,000. Hey, can you see that this growth is very similar to the lithium industry 6 to 7 years ago? So this is exactly the same fundamentals of the lithium industry. We are only going to put 4,500 tonnes per annum on, so we don't have a lot of capacity, but will be absorbed by the growth. Now let's look at the current producers. Like the lithium industry, these are big chemical suppliers. So Sumitomo, Sasol, which is a South African company, Bukowski is a French company, Hebei Pengda is a Chinese company. Now, typical of chemical companies, they tend to buy their feedstock to produce a product. The way they do it, to meet that 99.99% specification, they can't use smelter-grade alumina that Alcoa produces because it's got too much sodium in it, because they use sodium as part of the Bayer process. They have to use aluminium metal. So they buy this very expensive feedstock, they dissolve it using alcohol, they hydrolyze it, and they make alumina. But when you think about it, it actually started as alumina in the first place from the bauxite process. They made smelter-grade alumina, they add a lot of electricity and aluminium metal, and it goes back to alumina. So the question is, if you can come up with a process that bypasses the aluminium metal stage, would you be more competitive? And fundamentally, we have a process that is disruptive. We are taking straight from the ore to the 4 nines in one single step, bypassing the aluminium metal stage. And the only reason we can do that, look at the colour of the ore body we start with, it's a kaolin deposit. Now, as you know, kaolin is a very white material used in ceramics and paper. A lot of the impurities have already been leached out over the millions of years. So we use that as our feedstock. This deposit is in Western Australia. We have a 250-year mine life. And we are already well on the way of permitting, subject to the finance. We will begin operations in this. We are building this plant, 4,500 tonnes per annum. The capital cost is around 298 million US. We are building it in Johor. We selected Malaysia because of operating costs, and fundamentally also very strong government incentives. So we have something like a 5 to 10 year tax-free window to build this plant here. So you know Dyson, the UK company, they've shifted all their operations to Johor because of these very strong tax incentives. So our business plan consists of 4 puzzles. Because of this new demand in the electronics industry, we've got a great deposit, established technology that's been around since the early 80s, and great people. Let's look at the financials. So CapEx is something like 298 million. The NPV is $500 million. Internal rate of return is 22%, and the price is about $27 a kilo. The current price is $40 a kilo, so if you plug that into the model, it's worth 1 billion NPV. Now the question is, what about offtake? Well, we have offtake with Mitsubishi. They will buy all our product for 10 years, so we have an offtake partner. And on funding side, we are being funded from a German bank. So KfW IPEX Bank, which is owned by the German government, 185 million debt is now in the last stages of being secured, of which 165 million is export credit finance. So what that means is that the German government underwrites this project to support their suppliers, because 50% of our plant happens to be German equipment. Even our EPC contractor is also a German company, SMS Group, and they will give us a fixed price turnkey contract. They will guarantee the throughput and the process as well. So very strong risk management here. We're in the final, we raised 17 million about 3 weeks ago. We are in the final stages where we get the final approval on the 14th of December. 6 months of next year, we'll raise the project equity, 2 years of construction, and we hope to have a final product in 2020. So thank you very much. This is our growth over the 3 years. 8.5-fold steady growth in market cap, 350% increase in shareholder base. So thank you very much.